get going.
Okay, well, hello everybody, and welcome to. I think this is number 4, isn't it? Including the intro. So here we are, moving along at. I think we're covering a reasonable amount of ground. I mean, they're only an hour-long sessions, so there's a limit to what we can get in. But I think that I'm trying to keep it simple and basic, and hopefully we're not losing anybody. Let's get on with tonight. So until now, what we've done is we've obviously captured the data, we've extracted the data from our files, done some basic manipulation. We'll do a little bit more tonight, just to sort of spice things up a little. And we learn how to create a simple chart, a graph with some data represented on it, using pandas and matplotlib, which are the two primary libraries which we can use. Now, it's worth remembering that pandas has NumPy built into it. So a lot of people have asked me subsequently, why shouldn't we be using NumPy? Well, NumPy is part of pandas, so you can get access to a lot of what's in NumPy through pandas. You can also use raw NumPy as well. So NumPy is the actual mathematical element of pandas, and we've just had a short conversation there about MATLAB. So MATLAB is a different thing to these libraries in the respect that it's a modeling language which compiles, and then you can and it's very, very fast, and it's used by professional data processors. However, there's nothing wrong with the Python stuff, and that's used by a lot of professionals as well. But the nice thing about it is it's interpreted, which is beneficial when you're learning, like we are, because you can iteratively develop as your skills improve. And of course, all the stuff we're using here is open source and free, which is for us, a big bonus. We don't want to be spending thousands of pounds on software just for something that we're doing in our spare rooms. So tonight, what we're going to be looking at is plotting, learning how to present the information that you've put together, and that is information about how maybe the science behind how you've collected the information, maybe documenting that, and very, very loosely anyway, and then the results themselves, along with the Python code that we've used to generate the results. So the results generally being graphical charts or tables of data or what have you. And then lastly, we're going to look at how you can then convert that into a web offering, so that you can open this information in a web environment. So we're going to look at a really nice Python library which allows you access to some really, really nice interactive web-based presentation functions. So what we'll start off with, let me start by sharing my screen. If I can think of which one I'm going to, I might as well share the whole screen then. All right, okay, so there we go. If I go here, so this you should be able to see now my Visual Studio Code, and this is principally this is exactly what we did in our last week's session. So very, very quickly, we've talked about this already. Pandas that we've imported in there, which we use to read from the file and to create the data frames, these multi-dimensional data objects, and then matplotlib we used for the charting and representation. So this is some of the stuff that we did early on, just to sort of show you some of the sorts of things you can do with these tools. We ultimately we created a small frame for our the actual counts coming from the measurements coming from the detector, and we had another range for the time elements, and then we plotted them using this plot command onto a chart. And of course, if we run the whole thing, in fact, let's just run it just to remind us what it looked like. We ended up with I've just pressed the run. It's just I'm just waiting for this to. There we go. So we ended up with a chart which looked a little bit well, it looked exactly like that. And if you remember, this is interactive as well. We can zoom in on some of the data there, and we can move around. So the Matplotlib's got all of that sort of functionality built into it, and that's what we did last week. So we're going to build on this. So what I thought we might do is just put a little bit of supplementary stuff in here just to show you how you can start to manipulate the data from within here. Now, I'm not going to do anything really advanced. I'm just going to just show you that you can iteratively add to this. And it's something that somebody asked me about online later, which is if I wanted to smooth some of that data. Because if you look at the data that's represented on there, it's pretty sort of I don't know what the word is, but sometimes you need to smooth the data because there's some sort of periodicity going on there, which you're very much sort of statisticians always warn very carefully about using your eyeball as a way of doing science. So if you do see any sort of periodicity in something, it's always a good idea to actually attempt to model it mathematically. And one of the way that you can smooth things like this is by doing a sort of rolling average type approach to the data. So I thought I'd show you how we can overlay on here, because it's something that Dave's done in his, and a lot of you have commented on about. He's got this sort of a red trace overlaid, which has got other analyses showing and using the same data. So I'll show you how easy it is to do something like that. So what I'm going to do is create a Y here. I'm going to calculate I've actually put a comment in there to suggest where we should do it. So I'm going to calculate a rolling mean of the data coming from the detector. So I'm going to call that Y2, and it's going to be equal to, and to do a rolling average. We're going to create another data frame, and we're going to create it from. Unfortunately, I've got. Let me just switch. I'm just going to switch Copilot off because it's rather getting in the way of what we're doing. Status ready, Copilot chat open, disable completions. There we go. Okay. Yeah, I don't know if any of you are using Copilot, but it's sometimes really good to have, but other times, especially when you're teaching people, it sort of gives the game away because it completes all of the work for you very quickly. So we're going to create a data frame using this MV data. The only difference is that I'm actually going to create this rolling average. Now, the commands available to these data frames, of course, in Visual Studio, you get a really good clue because you can do the dot, and then you can see all of the methods available to you. And if you type RO, you'll see that there's one called rolling, and in fact, if you hover over it, or if you click on it here, it'll tell you all about it. And it's basically a way of operating a rolling average. So if you put the word rolling in there, there are then a whole load of parameters that you can pass to it. The parameter I'm going to pass is called window, and I'm going to say window equals 12, and that just means that it's a rolling average of 12 data points. So it'll take 12 data points, it'll calculate the mean, and then it'll move along one data point and do the same again, and then so we'll end up with a smoothed curve of 12 data points. Now you can do that based on any element. So if you want to do a mean, you just do mean like that. Mean is a method, so it needs parentheses on the end. But you could also do other things like you could do median, or you could do maximum, minimum. All of the functions are in there. So you can see now that these data frames suddenly become really, really easy and nice ways of manipulating this data. So that's not only going to calculate sort of one value, it's going to calculate for the whole data frame that we've headed it up with. And in fact, it will do it for a multi-dimensional data frame as well. So if I've just used one column, or one element here, but you could have multiple elements and it would do something similar for both. So I definitely advise you to have a play around with that. So in order to add another plot onto this particular one, well, the first thing I'll probably do is the plot that we created. It gives you the line graph. That's what a plot is. In order to make it just look a little bit better and just to show you some other functionality, I'm going to change that to a scatter diagram. So if you change plt.plot to plt.scatter, we're then going to get a scattergram. So we'll get a load of data points. As I say, it's not necessarily what it just shows some variability here. So what I'm then going to do is add the actual data frame we just created, this Y2 data frame. So I'm just going to do PLT dot, and this one I'm going to do as a plot, because I want to have the averaged value as a line, and I am going to say X and then Y2, which is the field that we just created, and then I'm going to have a label for it. So I'm going to say label equals, and I'm going to say what it is. So it's a rolling mean, mean, and I'm going to say 12 point window, so that it's obvious to anyone reading it. And the last thing I'm going to say is what I'm going to say. I want the color to be spell color. Of course, I have to spell it American way. Color equals, and I'm going to say I want it to be red. So I'm going to have the default color is blue, and you can choose any color you like for these graphs. So that should draw a second line on our graph with those values superimposed over the top. There's nothing else there we need to change. So if I run that now, so we should get the new value. So there you go. So now we've got a scattergram instead of a plot, and we've got a rolling average value with a line. So you can sort of see that periodicity that we spotted with our eye, but it sort of proves that there's something there. I have no idea what that is. Probably something to do with the way that the sampling of the data is being carried out. I don't know whether it's anything actually astrophysical at all. I doubt it. But that's the sort of things, obviously, that you need to do. So this gives us a nice chart printed out on our screen. Now, we also learned that you can save those. You can save that to a file. You can have a command that saves it to a file. In fact, I think we'll probably we'll do that slightly differently in a moment. So that's how that's basically where we were at last week, although we've just enhanced it slightly with a second plot there to show you how we can start to manipulate that. So what we're going to do in order to what I'm going to do now in order to generate actually let's first of all I think before we do the web bit, we'll go and do some presentation. So if you've developed a piece of code like this and you want to talk to somebody about how you went about working all this out, one of the really good ways of doing it, and somebody was talking about interactive Python. Interactive Python, or IPython, is something that's been around for a very long time, but it's now been sort of renamed Jupyter Notebooks. It's now part of a much bigger suite of presentation and data manipulation tools, and it's very, very popular in data science and in the academic world. And you'll find Jupyter Notebooks now covering loads of different topics, and it is a great way of documenting. Just even if you're just doing sort of simple experiments yourself, and occasionally I do that, just the same thing myself, and I quite often will create a Jupyter notebook just for my own record of what I'm doing, because writing notes on bits of paper and trying to remember how you did it, and especially when you're having to research how to do things as you go along, it's worth putting all that into one of these notebooks, because they're great general purpose ways of keeping all the information together. So what is a Jupyter notebook? Well, let's open one. If you're in Visual Studio, Visual Studio knows all about interactive Python. It knows all about Jupyter notebooks. So you can actually go into the file and you can say, I want a new file. And if you click on New File, you'll see that one of the, it pops up at the top here, and it says, do you want a text file, do you want a Python file, or do you want a Jupyter notebook? So I'm going to say, yes, I want a Jupyter notebook. Now, a Jupyter notebook is a file which has got an extension IPYNB. You can go ahead and we can go ahead and save that. We'll save it as rather than just keeping it as a default. We'll keep it. We'll call it Muon 1 or something like that. And so we'll save that. Now at the moment, you've just got this empty file, and it's got this. I forgot what they call a cell. You've got a cell in here, and this cell is either going to be, and in fact, this is actually how you add another cell. So in a minute, we're going to go on and add more cells. But the first cell that it creates, there are two types of cell. There are markdown cells, which is basically a text editor with its own sort of language, and then a code cell where you can actually write code. You can write any type of code you like, so it'll support all the languages, Java, C, everything you can imagine, and of course Python. So this is the interactive Python element. So what we're going to do in here is we're going to, I'm just going to take you through some of how you would start a Jupyter notebook for the purpose of what we're doing. So I'm going to say this is called Muon data processing as a title. So if I type that in there, and actually, no, let me just, you have to say what environment you want, Python environments. So you have to select which version of Python. Now, unfortunately, the first cell that I've created is created as a code one. I don't want code, I want a markdown. So I'll put that back in. So we're going to say Muon data processing. Now I want that to be a heading. So in order to put a heading, I just put hash in front of it, and it becomes a heading. So if I actually now just hit Control Enter or the tick box, you'll see that it's now gone into bold. And the reason for that, and if I double click that again, I can go back into edit mode. This is the markdown bit. Markdown is a language, a text language, which allows you to use annotations, and that hash means this is a main heading. So when we actually run this, and you can see there's a tick mark there, if I tick that, you can see that it's going to present that in a particular way. So if I want to another line underneath there, I can say I want another, here it says markdown. I can click on markdown, and I can put session 4. This is going to be not a main header, but I'm going to make this, I'm going to put 2 hashes, which means it's a second header, and then you'll see that it's not quite so big. Now, how do I know what all these markdown commands are? Well, that's pretty easy. If you go to the Tinterweb and you type markdown, I just typed in markdown cheat sheet for a very quick abbreviated one. You can see here there's the headings. There's heading 1, 2, 3. If you want to do bold, italic, You can do lists and bullet points, and you can put inline code, you can put links that you can click and they take you to places. So there's all sorts of things you can do. So this is the cheat sheet, so it's an abridged version. If you go on the basic syntax, there's a link there called basic syntax. That takes you into more detail, so you can see all the different headings, you can see what happens, and it's got lots of how to use it, how to do paragraphs, how to. So it's a little bit geeky, but you end up with some nice formatting, and it can format things, quite complicated maths and stuff like that in there. So it's worth learning some of the basics at least. So the idea behind it is that we can make some notes in here as we go along. So I'm going to add another one in here. I'm going to say start by importing the libraries needed. Okay, so again, that's a note for myself. You can add any text you like in there. So the next cell I'm going to do is going to be a code cell. So in this time, I'm going to hit code. So this allows me to put Python directly into my notebook. So I can say, as I've just pointed out, I'm going to say import pandas as PD, which is what we do in our main program, and I'm going to say import matplots plot lib as plt. That's not right, so it's yeah, that's better. Matplotlib as plt. So you can see that all the syntax highlighting that you get in the main editor is also in these libraries. And then we can say print PD, which is the instance, the pandas, and in fact it was there, wasn't it? So double underscore version. There we go. So that was the first piece of code that we typed in our main session. Now you'll see now that there's a little play symbol next to it here. There are also some others, and I'll talk about those in a moment. But if I want to see this work, I literally go along here and I hit the play button, and you can see, look, it's printed out 1, 2, 3, which is the version of pandas that we're using. So it prints it out immediately underneath the box where we are. So we can now put together, start to assemble all of the things that we're going to need. So the next thing I'm going to do is I'm going to put another in the next cell down. I'm going to put some more markdown, and I'm going to say then we can import the data using pandas into a data frame called df. I'm not going to spend too much time typing these in, and you get the general idea. So you can start to see that we're putting together a useful document, and the next bit we're going to write some code in here. So I'm going to say df equals pd dot read CSV, read CSV, which is there, and we called it what did we call it? Data1, I think, wasn't it? Data1.txt was our data file, and I had a separator of equals space, which is that, and I also did skip rows equals 6. That was the data frame that I imported. We'll come back to that one in a moment. I'm going to do another markdown on here, and I'm going to say now we can print out a few rows, and I'm going to, oops, try to put that in the wrong place. Code underneath there, and the code is going to be df dot head. Oops, finger trouble now. df dot head. If you remember, there was a command called head. Now, you'll see that if I try and run this now, it'll fail because it doesn't know what df is, because I haven't yet run this piece of code. Can you see? So I can go up here and I can run this piece of code, and that's now got a check next to it. So this will now run now, or I can use one of these commands. So this particular one is execute all the code below this point. So if I click on that, it executed that, and then it executed that. So there's my data, the results of my df.head. So bit by bit, we can add these things together. So if you decide that you want to have, instead of 5 rows, you want to have 8 rows of information, you could click that and then just do that, and you would end up with 8 rows of information. If I wanted to skip, 5 rows, I could hit that and click that, and it would do oblige with whatever it is that we've done. So it's really nice for iterating your code and generating all the pieces as you go. Now, ultimately, if we were to put, in fact, let me see if I can just copy these from. Yes, if I go, I'm just going to try and do this. So whether it will work or not, I don't think it will actually. No, I've actually got a completed version of this here. So all these files, incidentally, today I've put on a Git site, and at the end I'll show you how to access that, where it is, and how to load it up into your Visual Studio, so you'll be able to get all of this, all of my work anyway. So this is a completed version of what I've just been showing you. So you can see now that, and if you go to the top, you'll see now we've got this thing that says clear all outputs. So if I do that, you'll see that all these, let me just get rid of this at the bottom. You can see that all the outputs have got nothing under them. And you can also, you can say run all from there if you want. So if I do run all with Python 8, yes, it will run through all of these. So there's the first one, second one, third one, fourth one, there's the head, and ultimately there's the chart. So if I wanted to make this into 14 points, I would actually have to change it in 2 places. If I wanted to do a rolling average over 14 points, I would change 14 there, and I would change the label as well, probably to there, and then I would run the whole thing from this point downwards, would probably. So if I run that and do run from here downwards, we've now got, it now says 14-point window, and we've got a slightly different average. So that's the beauty of these, is that you can use them as, I mean, and you can publish this now to a PDF or to a web site. So you can publish these in their raw format, and they'll work directly as a web page, or you can use them in presentation mode, like a PowerPoint. So you can talk, if you were giving a presentation about what the work you've been doing. In here you can have obviously pictures and diagrams and all the information about the science behind it all, as well as the code which is generating all of the data, so that people can review your code as well, which is always obviously what you need to do in a science environment. You need to have the peer review directly as you're producing the information to validate what you're doing. So that's a Jupyter notebook, and you'll find a lot of these available in astrophysics and astronomy in general. You'll find these Jupyter notebooks, and they can become very sophisticated. We've only just sort of touched the surface of what you can do in them, but I think you can see that there's quite a bit of capability there and power, and you can there are some I can't actually see it because there's bits of zoom in the way. Over on this side here, you can copy the image to a clipboard. You can expand the image so it'll open it out in its own. It's not particularly impressive when you do that on that one, but and you can save the image to disk as well. So there's also, if you sniff around, there's all sorts of little ditties which allow you to play around with this stuff. But yeah, you restart, which restarts the kernel. So if you manage to really bugger up all of your data and everything, you can just restart the kernel, and you'll see a little thing come up there. You can clear all the outputs, and then you can either run all, or you can run it one by one and see what. So that's the first one. If you want to run them one by one, I can. Second one, so you want to test your code to make sure it's all okay. You can go down, and I'm running these one by one. There's the head, and now the plot, and there we have our graph. So it's very useful even just for yourself, because it reminds you of the way that you built it, and you can describe in more detail in these sections what your code's doing, rather than relying on a few comments, which is never totally satisfactory. So let's go back to our program, and we'll have a look at generating this as web content, because that's the next thing that some of you are interested in doing. And there's a really nice library available for doing that. So if we go back to our simple plot program, so this, if I run this again, we know that it will generate this. So what I'm going to do is I'm going to use a couple of new libraries. Actually, one library I'm going to use. Now, there's a fantastic web tool called D3, which this is the website for D3. It's actually a JavaScript, web-based JavaScript data visualization tool. Very, very, very high-end, sophisticated project. This, I mean, it's used massively in data science as well. So you can do really funky stuff like this sort of thing. So you can get sort of graphs like this, and these are actually dynamic as well. So you can, if you scroll down, I might find that particular one hasn't got dynamic features in it, but some of them have. You can click on any of these, by the way. So if you take something like, well, I don't know, I'm trying to see if there's one there that is dynamic. There's all sorts of really weird, wacky ones. You see how that sort of actually was dynamic. You can, some of them have faders and things like that you can play around with the data. I should have lined one up before I started here. I think this one has. So this is yeah, okay. So we can. This is a what do they call it? Baseball statistics. Passing yards. Select stat. Passing yards. I picked another one that I don't know how it works as well. So anyway, this is the actual. There we, yeah. So it's now drawn it, and sorry, I'm clicking on. But this library, which is actually a JavaScript library, there is actually a Python library which allows you to use it, and it's really simple to use, and it's called MPL D3, which stands for Matplotlib D3. It has a website as well. I think did I put? No, that's a Git thing. Yeah, that's something else that I was doing for my day job. I can't find it now. I did. There is a website anyway with. I thought I did get it ready, but that's Matplotlib. That's there it is. Yeah, it's not a particularly impressive looking website, but it's MPLD3 is the name of it, and it allows you access to all of that really, really clever dynamic web page stuff. So that's what we're going to be using. Now, don't be scared off by it, because it is pretty easy to use. So, well, in fact, I'm about to prove to you how easy it is to use. So the first thing we need to do, now you have to install it. So if you haven't already got it on your machine, you would have to do pip install MPLD3, and it only takes a minute to install. Once you've got it installed on your, and if you if you want to install it, you just type that in down here. So you just do pip install npl d3 like that, and it will grab it from PyPy and install it. There you go. I mean, it's already installed on mine, so that was pretty quick, but it doesn't take a great deal lot longer. Now, the first thing you've got to do to get it into your environment, of course, is to import it. All these libraries have to be imported. So if I do import mpl d3, there we go. There is it's now available to us in this program. Now, in order to feed it, we have to create what's called a fig. And a fig is basically a chart or a diagram or something, like a figure in a book, and that's generated by pandas. And so all we need to do is, in fact, I'm going to put it here: create a figure and access to plot on. So in order to do that, I'm going to call it fig, so you know so you know what it is. So we're going to create a namespace called fig, and into that we're going to put one of these figures. And all it is it's like a canvas, if you like, where you can draw matplotlib objects. And it does give you some advantages, even if you're just using matplotlib without using the D3 library as well. It's plt dot figure, and this is going to create our figure, and I'm just going to say fig size equals, and then you would need to say how wide and how high we want it, and I don't know what units this is in, but I'm going to do 16 by 6. Actually, that has to be in its own set of parentheses, because it's a tuple. So tuples have to go in their own set of brackets. So that's a canvas where plot will now draw. So all these plot commands will work just the same. It's just they're going to be drawn onto this fig now. So I can manipulate the outside, the whole shooting match, if you like, and I'm going to pass that into the D3 library using that fig. Now I could just save. I can. What have I got in my notes here? Plot the rolling mean. We've done that. I did that, right. So I'm going to show you how you would save the plot, which we know we can do from an icon interactively, but in line we can do it as well. So if I do plt, which is sorry, I've got a mental block. PLT, which is the pandas object. I'm going to call a method called save fig. So you can see that there. So we have to save this figure to a file, and we're going to pass the contents of the file. You don't have to use an actual physical file, but it's easier to show you this way. So we're going to pass the contents of the file into D3. We'll call it, we need to give it a name, the file, and I'm going to call it simple plot, which is the name of my program, .png. It's going to be a PNG file. So that will write into our memory. In fact, you probably can see that I've already done it. It's there. So this bit of code I was running earlier just to test it. So that's what I did. But we've basically created in fact, we can run that now and I can show you. So if I run that program, it's just loading up. There we go. That's the actual plot. So you can see now it's a bit bigger because I've put this figure in place. Still got the same tools available to it, slightly bigger because of that command. So, but it's the same data as that we just generated earlier in a slightly different appearance, and that now is also here. So if I click on that, that's got a PNG browser built into Visual Studio Code, so you can see it right there. So has saved that into the local directory, because I didn't put any paths or anything on there. You can put a path on there and obviously put it wherever you like. Now, in order to generate a web version of that, we then have to pass it to our D3 machine, if you like. And to do that, I'm going to tell you what I'm going to do. I'm just going to comment out this line of code here, because we're going to end up with too many graphs appearing everywhere otherwise. So underneath here, I'm going to actually now generate the HTML version of what we've just done. So I'm going to use a context manager, because we're actually going to be opening a file, which is our HTML file, and I'm going to do it with the normal file command. So rather than opening it and closing it and managing all of the stuff that goes in between, I'm going to use the context manager, which I taught you about on the second week. So if we do with open, open being the file command, that then means it's going to be completely managed by the context manager. It just makes it a lot neater and more reliable. The file that we're going to write is going to be an HTML file. I'm going to call it index.html, which is a fairly typical name for a file that you would an HTML file. And I'm going to open that file as a read-write file. So a W is how you signify read-write. There's all the different versions. So read-write, append, and all the rest of them. But we're just going to write to the file, so we just need a W. And then we're going to give it a handle, so or a namespace, and we're going to say as, and I'm going to call it HTML_file. So that's going to be the namespace for this context manager to work with. So from now on, I'm going to say HTML file when I'm ever referring to the file, the HTML file that I'm writing to, which, you know, fairly sensible naming. I'm a big believer in it. So in order to write the information from the D3 tool, I have to. Oh, I missed something out. Right, I'm just going to put the word pass in there for the minute, because we haven't actually written the data yet. I forgot a step. So we need to generate, before we can write that our HTML file, we need to generate the HTML, and the HTML is basically a stream of it's a string. It's a string. So a big long string with a load of HTML code in it. So it's effectively the web page itself, and it's a stream of information. And I'm going to call that I'm going to call it HTML str, which stands for HTML string. That's just a namespace. So any old name will do for that. You can call it what you like. My web page, whatever. But this is going to be a stream or a string. If we were to look at the type of this object, once we've created it, it would appear as a string type. And we're going to use the MPL D3 library, and we're going to operate a function or a method of that library, which is called fig to HTML. So we're going to take our fig, our figure. So fig, you can see it there, fig to HTML. So we're going to take our figure, and we're going to convert that figure into dynamic JavaScripted HTML, which sounds terribly complicated, but and probably is, but I don't care because it's really easy. And all I have to do now is pass it the figure that I created here, which we called, if you remember from here, we called it fig. So that's my figure. And that is now going to create the actual HTML. So it's one line of code that's going to generate all the HTML that we need. And then all we need to do is then write that out to wherever our web server is. So this could be a directory on a Raspberry Pi, or on an Apache web server, or wherever, or just a local file if you were generating them manually for your own purposes. So all I need to do now is say HTML file, which is the name of my the file that we just created, dot write. What do we want to write into that file? Where we want to write the string that we created above, which is our HTML str. So we're going to take that stream and we're going to write it into the file. So that's basically it. So let's run this. So nothing should happen other than it should say done. I put the done on the end just so that you can see that it's got to the end. And now we should have an index.html file, which we have. Now, if you want to open that file, I don't think it won't necessarily open in Visual Studio Code, not without doing some fancy footwork. There's an extension which I'd highly recommend you put in if you haven't already. So if we go to extensions, which is where the little building blocks are, and click on there, if you type in the extensions search box at the top, if you type in the words open, it's always the one at the top because it's the most popular. It's called open, and it says opens the current file, and what that says is there with the default for the operating system. So I've installed that. I mean, you can click on it now. It installs in 20 seconds or so. But what it does is it adds, if I go back to these files, it adds an item into the context menu. So if I go onto the HTML index.html here, and I right-hand mouse click, you'll see that at the top there's a new entry that says open with default application. And it's ever so useful. So it means that any file type that's inside Visual Studio Code, I can open it. So if I click this, it'll open with my browser, and there you go. And there is our interactive version of our data file. And to prove that it's interactive, there's some little icons down here. So I can click on the zoom, and I can zoom in. I can then go back here, and I can get the data, and I can move around, and I can click on home. Now, if I wanted, I could also put, I could have other information on there. You see how I can pick up various elements of the graph, and that library, the D3 library is immense. So you can add all sorts of controls on here for filtering your data and such like, and you can get really, really carried away. This is obviously just reading directly into my browser, but if that were on a web server like Apache, that would be obviously available to anybody that clicked on the link. And the link could, of course, actually run some Python code, which would then generate all the last bit that we've just done, which we've done obviously manually, but it could run this code based on parameters being passed back from D3, and it is possible to do that. So if you want to launch, you could make this launch the browser directly, and there is actually a built-in library. If we go to the top here and do import web browser, there it is. So that's an inbuilt thing. If I do import web browser, once I've created this file here, what I can do at the end there is I can say web browser dot open, and the name of the file, which is index.html, and if you want it to do it, HTML, if you want it to do it in a new browser, do new equals 2. That just sort of cleans up any old version. So if you do that, when I run the code now, it'll actually launch there you go, it launches it directly into it, which is exactly what we just did, but it cuts out the manual bit that we had. So if I close all those down now, they're all shut down now. I run this again, you'll see it does it clean into the browser. There you go. So in order to generate HTML versions of those little bit charts, that is all we had to do, was operate this one line of code, save it as a file, and then open it in a browser. That's basically all we're doing. So very, very simple. Now, these libraries are obviously, this is really the tip of the iceberg. If you want to get into the stuff that you can see in the examples I was just showing you of D3, then obviously there's more things that you have to do, but they've got loads of examples in there, and you can insert lots and lots of commands and code in here to manipulate these graphs and such like using these tools. It's an excellent place to start because it's so easy to get on the road with, and then as you get more confident with it, you can learn more about it. The documentation's not bad, you know. I understand it, so it can't be that bad, and hopefully generate some pretty professional looking results. So that really brings us to the end of the collecting, manipulating, and presenting data. There are obviously lots of other tools out there that we haven't looked at, but I wanted to keep it nice and simple. And I think you'll agree that for how many lines of code we've got here, I think no more than about 40 to 30 lines of code, we've got quite a powerful little application already. Now, obviously, to turn that into something which is going to start manipulating and changing all your data, it's going to end up with more stuff in it without a shadow of a doubt, because you want to put more variables in there so that you can manipulate the values more easily, and things like the averaging that we did, you know, have some user input for changing those values in order to see what the effect is when you're developing it. But the Jupyter notebooks are quite good for that anyway, because you can just keep tweaking your code and adding more comments in the markdown sections, and you end up with some, you know, quite well documented and nice to present solutions. We've got 7 minutes left. If anybody has questions, then please fire away. Does that are you all sort of reasonably excited about some of this stuff, or are you sort of fearful of it, or have you already have all of you already surpassed this and you're all already into these things already? I don't know whether I'm hitting the spot with this material, but
yeah, I would just like to say I've never considered Jupyter notebooks before, and this is my kind of first exposure, and that was just brilliant, Roo. That is just so helpful. It's a good introduction as to the scope of what's possible.
If you treat them once you learn the basics, which are these cells, and the cells are only ever just like text and images, and then code blocks. And the way that the code blocks feed each other, you know, once you learn that, you're away really, and it is a much better way of documenting your code. If you develop your code like we have been doing together in a program like this, you're reliant on things like the comments. When you come back to look at this in 6 months' time, you'll think, why did I do that? What was the idea, the thinking behind, you know, like for instance, my averaging thing. Now, it doesn't say why have I got this rolling average? Well, if you do it in a Jupyter notebook, what you could say is that, you know, I'm doing this rolling average because I spotted a trend and I felt that it needs to be developed, and you can actually document the reasoning behind it, as well as, you know, seeing the code being inserted at that point. So I think it's definitely I like them. I think they're great. I can see why it's used in academia, because it is a way of for other people to see the way you've done things, not just the way you've done them, but your rationale as well.
Rupert, thanks. I mean,
I have a question.
There are two of us. I think that's it. I'll hang fire. I'm David, but I'll step back. Whoever else speak.
I don't know who the person was.
Just a quick question from me. Apologies for losing the signal, but what the Jupyter notebooks are fantastic to document the code. At the end of the day, though, extract code into a single file sort of from a command line.
Sorry, what was the last bit? We missed it.
from online Python, you have to extract code out of the notebook to do that. Do you understand what I mean?
You broke up. You said something about a landline, and then you said extracting the Python code, and then so I didn't quite get it. Are you saying that if you were writing a program, how would you then extract all the code into the program?
Yeah.
Yeah. Well, if you were writing. The Jupyter Notebook is really more about documenting a process and a scientific sort of in a scientific way how you develop something and how you develop your code. If you then wanted to write a program that actually had GUI and functionality and all the rest of it, you would probably develop that alongside. I mean, there probably are ways of exporting all of the code as one big block, and I've never really. I mean, I've never really explored how you would do that, but I dare say there are tools for doing what you've just said. There's a lot of functionality that I've got no idea about because I don't use it day in, day out. But I do use it for teaching. I teach some of my day stuff with it, but I use it for showing a process, if you like. So it's a step-by-step guide. Whereas if you're writing an actual application, then you're going to be just using Visual Studio and writing it as application. I don't know. Is that the answer to your question? I don't know because I didn't really get. Did anybody else understand the question, or maybe you could say it again?
Yeah, sorry. I'm on a very, very poor Wi-Fi here.
Right. That was the landline reference.
I keep dropping out. Yeah. It's a wonderful tool for documenting your code. I can understand that. And it's just at the end of the day, if you want to run that from a Python command, it was just how to do it.
I see. If you were going to use this, there may well be ways of doing it. To be honest, you can probably open a notebook and get it to automatically run. I mean, there's a button at the top there, called Run All, and you can click that and it generates the thing at the result at the bottom. I dare say you can actually, because there's a command line interface for this as well, and then maybe scripting available within Visual Studio for doing it too. So I dare say you can do it where it will you can get it to open and launch it all and run the code at the same time. I'll have a look. I'll see if I can find the feature and I'll let you know if I can do it. But I'm fairly sure you will be able to, because it's the sort of thing that, yes, I can imagine people wanting to do. Yeah.
David.
David, yes, you had a question.
David Salmon, you had a question.
Yeah. Thanks, Paul. Rupert. Yes, I mean, I'm not familiar with this particular package, but I've used other plotting packages in the past. I'm presuming there is somewhere in this sort of package of methods associated with the plot a way of adding error bars to things.
Absolutely, there are. Yeah.
Right, because broadly speaking, one of the problems I have with a lot of the plots that get shown on the list is because they have no errors on them. I have no ability to interpret them. Because you just can't estimate the significance. If people are looking for, let's say, anomalies or variations in the rate without some determination of an error, you never know whether those differences are significant or not. So I'm curious, A, to know the mechanics, but B, what I'm trying to do is just to plot, rather than taking a rolling average, is just to sort of block things up. Yeah, just take 15-minute slices. A raw estimate.
Yeah, rather than just having a specific value.
Yeah, the problem is if you use a rolling average, everything just gets correlated, and I actually don't know how to handle the error in that case.
As I said to you, I'm not a data scientist, so I know that rolling averages are something that you can use for certain types of data.
Yeah.
It was purely a way of, because somebody had asked me how do I do another plot over the top with some of the data on it. So that I picked that because it's easy to understand.
No, it's a good idea, but this is the sort of the mechanics. It sort of belies sort
it's
of
one line of
underlying.
code here. Look,
Yeah.
bar.
Okay, right. So the rider to that is then what might the recipe be by means of which you could put numbers into that thing, which that's a separate question entirely. Yeah.
Well, the numbers would come from these data frames. So these data frames are 1, 2, 3, 4, however many dimensions of data that you have.
Yeah, I think I understand the mechanics. I'm more talking about
Yeah.
in principle is on what scientific basis would one ascribe
Oh,
an
I don't know the
error to
answer to
any
that
of
one.
these?
I'm sorry.
Well, I think this is a useful one to leave hanging, perhaps.
Well, that's what we said that we would have. We ought to do a follow up in maybe 4 weeks time, when
Yeah.
everybody's had a play around with this and started to generate some pretty graphs. Is then to talk about the reality of what pretty graphs are capable of showing, and like you say, what things you need to take into account. Which things like, you know, you've got to validate your data. You've got,
Sure,
and a lot
yeah.
of the time. I mean, the periodicity that I keep talking about is, I'm absolutely positive that will be something to do with the way the sampling works, and it's just reflected in that. So you can get very easily fooled, can't you, by data?
Yeah, well, indeed, artifacts, and that's why I think you know, taking all of the, you know, these sort of practical methods and somehow combining them with a, let's say, more precise statement of what's trying to be measured, and then following from that some objective means of trying to ascribe an error to it, and then we can wrap it all up with this kind of methods that you're showing us. Yeah.
But that's what the Jupyter notebooks I really like about them, is because
Sure.
you know, your washing's out to dry, and everyone can see it, can't they? Whereas if you've got a very complicated program, wanting to call it as a whole, quite often a lot of these functions and things can be very hidden, and it takes almost a computer scientist to decipher what's going on. Whereas with a Jupyter notebook, you can, if you present your information in the right way, that is, you can see plain as day what's going on. So you'd be able to look at it and say, well, hang on a minute, you know, you've got this error calculation and you're using some, you know, some factor in there which is creating an anomaly. So that's the beauty of it. One thing I wanted to go on to, hopefully that's, yeah, we've had that conversation. I've posted all of this onto Git. If you go on to, this is the place where you find it. There's the actual URL. And in fact, I think Paul has sent the URL out onto the groups. If you click on that, it'll take you to a Git site here, which is beginners Python for Muon detection and data processing. So it's basically all the materials that I've been using until this point. If you want to get this into your Visual Studio, I can very quickly show you how to do that. If I create I'm just going to create a new window, which means a new, so this is a completely fresh Visual Studio instance. And you'll notice that at the beginning here, it's got this thing that says clone Git repository. So if you click on that, it says, where is the Git repository you want to clone? Well, the Git repository you want to clone, if you go to the Git repository here, where it says code, you pull that down, and there's a copy to clipboard symbol here, look. So you click on that, it copies the URL into the clipboard. You then go back to, well, you got to do it again because it's cleared, but clone to Git repository, and you paste that into Control V, Control V, and there is the actual URL that we just copied. So you say yes, clone from there, and it'll say, where do you want me to put it? So you have to give it a directory. So let me just put it somewhere where I can, I don't know where I'm going to put it. I'll tell you what, D, projects, BAA, and we'll put it in one called, well, just put it directly into, well, actually, no, I'll put a new folder and just put, I'll call it blah, 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 just so I know it's junk. I've got a lot of directories called blah, 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 by the way. So you choose the directory you want it, select the repository destination in the button below, and it says there, and it says, right, I've cloned it. Do you want to open it? Yes, open it, and it'll open the project. And there you are. There's all the stuff that's in there. And if I make any changes to that, if you really want to, you can go in here into the actual source control, and you can do a pull, and it will get the latest stuff. So if I update any of that, I'm not likely to, because it's obviously unless I find some mistakes, but I think it's all functioning. But that's how you can clone into here. There are other ways of doing that, but if you're using Visual Studio Code, that's really nice and easy. You just do the clone thing.
Very good.
You can also, with a web browser, if you go there, you can just click on the, for instance, if you look at the Jupyter Notebook, interestingly, it's Git's pretty good with Jupyter. It actually allows you to do stuff. You can actually use it in line here. So, oh, actually, you can't. I thought you could actually run it. You can't actually, no. But it does actually run it all and shows the output here. You can't actually edit it on the fly, unfortunately. You probably could if I gave you the permission to do it. Yeah. But again, you get quite a nice view of it from in here. Oh no, we don't want to look at that. That's horrible. That's all the HTML code, by the way, that's generated by the graph. Actually, it's not too terribly complicated, that one, but there's a lot of JavaScript in there which I don't understand. Any other questions? Oops. And in fact, if you're doing the original Python workshop, that's here. That's all the code for that. And in fact, I did that with Jupyter Notebooks as well. Click on that. There's a load of Jupyter Notebooks in here. If you go to Pico or one of these, yeah, here we go. He says there we go. There's Jupyter Notebooks there about well, it's just about Raspberry Pi Picos actually, but you can see now how you can put images in there and such like links. You can click on links and they can take you to places. So it's pretty good.
Well, most excellent, Ru. Just as a closing comment, if anybody's got any questions that come up from tonight or any of the sessions, or as you're mulling over and playing with what we've been doing, then do send them. You can either post them on the forum or send them to me, and we could have an evening of Ru addressing those specific questions, because if you've got a question, it's quite likely that somebody else has got the same question. So just bear that in mind. Other than that, I just want to say thank you so much. Thank you so much, Ru. Excellent
No problem at all. Yeah, thank you for all attending and bearing with me, and hopefully it gives you, if one or two of you start doing a bit more Python, and hopefully we can get something out of these Muon boxes, because there's a lot of them out there now. I've got one here. I almost send you this back, Paul. But I haven't actually collected much data, ironically, from it. But there's only so many hours in the day to do all these things, aren't there? And
yeah.
But it gets a lot of Muons. Did you see that thing I sent? I've started finding out more about Muons, but that interesting paper about in the Ukraine, University of Kiev, somebody's done a PhD on it, and it's using muon detectors for basically looking inside shipping containers. Did you see that article?
I did look at that. In fact, there's been quite a few published papers on muon tomography.
Yeah,
I think they did a tomogram of the giant pyramid, and we had a guy from a prof from Sheffield University who was using it to map old railway tunnels. Wow. Where the vents had been filled in and may be likely to collapse because it wasn't done very well.
Right.
So the density of the vent shaft was much less than the overburden. Yeah, yeah, very interesting stuff
But
indeed.
that technology is definitely going to benefit us, I'm sure, because you know, the tomography software and everything looks pretty sophisticated, and if that comes down in our direction, it could be very useful,
Rupert,
as well as the actual detectors themselves.
Rupert, there has been something in the physics world, the Institute of Physics magazine, in the last 18 months at some point. I'll try and dig out a reference to it. But was it you who were also asking about machine learning algorithms in astrophysics?
It was, yeah.
I did a bit of poking around, and there's been some conferences on it. I found a review paper. I've got no personal experience.
No, I mean, I've read a few of the papers, online papers. They're pretty heavy duty.
Well, as you'd
imagine.
yeah,
quite. I was more, I'm sort of interested to see what the way in which the learning stuff, because I've done quite a bit of the AI learning stuff, mostly with imaging, and I understand the mechanism of how to do it. But what I'm interested in is how they're applying the learning to processing, to data processing, whether they're doing it through, you know, whether they're charting it and then using imaging. The motivation behind it is for the detection of meteor detection from scatter, Doppler scatter spectrographs, and because they're pretty easy to spot as a human, but not so easy to spot as a computer. And most of the attempts that people have made with computers have been pretty unreliable and pretty poor. Yet you can look at a spectrogram, and you can be pretty accurate when you spot an actual meteorite rather than an aircraft or a satellite or something.
Probably the best paper I found was a review paper from the last couple of years. I think it was astroparticle physics, I think. But you're right. It is heavy, but it was introductory, and it was trying to sort of lay out what the landscape was before getting bogged down into too much.
They've done a lot of it at CERN, haven't they? I've noticed.
Well, it's moved on a lot. I was in that field 30 odd years ago, but the algorithms are radically different now, as are the detectors. So I don't actually know in any practical sense how it's done, but I was hoping to get something out of it, even if just in the broad sense. From
I just want to understand how they present the data to the model, really. You know, whether it, as I say, whether it be actually graphically or whether it is in some other form, and the neural networks work in a slightly different way.
My one observation on all of this, and I think it also is reflected in that study paper that you pointed out, is that they've got enormous numbers of channels in comparison to what we've got, which individually we've got a pixel each. And one can argue how that might be.
Oh, you mean for muon detection? Oh, yeah, that's
for sure. But even that study paper you pointed out, I think it was sort of hypothetical. I mean, it is being done, as Paul noted, but there were, I don't know, tens of thousands of channels in that thing. Yeah.
Oh, you mean for the container, detecting containers?
Yeah. So
they were talking about arrays of.
There's like so much more to feed into a neural algorithm there.
It would cost you millions just for the detectors, wouldn't it? I mean,
they're not straightforward.
No. No, I know a lot of it was theoretical, but that's a good place to start, isn't it? If you can prove it theoretically, it generally follows that, 10 years down the line, someone will build a working version, and it goes from there. But
I think my difficulty was essentially, given we've got so little individually from the detector, I'm not even sure what you'd feed to an algorithm of that nature.
No idea. But that's a nice place to be. We're at the beginning of the technology, where we're getting information from space, but we don't what it is and what to do with it, and that's a great place to be. It's like thinking about like the cosmic background, but back in the 1920s and 30s when they were just discovering what that was. I often think, wouldn't it have been great to be around then? But actually, it's just like this. People didn't know what it was, and we don't know. I mean, we know what muons are, but the information that we're getting from it, we don't really understand.
Yeah, one thing that might be worth pursuing very specifically is to see whether the Pierre Auger observatory is actually using anything like machine learning to.
Is that one of the big muon
yeah, it's one of the
observatories,
things uses Cherenkov radiation to detect
Yeah,
particles. So,
right.
but they've got a lot of channels. But nevertheless, it's where you might get some insight on that kind of algorithm.
I assume one of the things that it would be nice to know is the direction in which these particles set out from. That's something that people want to know.
Well, that's what the Cherenkovs really do give you.
Because it's a big tank of water and you can see
you get a cone, so you get a ring of light, and so you can tell a direction from it, which you know their angular resolution is much higher than anything we can dream of.
These plastic scintillating things don't do that, do they? They just go, something hit me and that's it.
Yeah, our field of view is essentially it's not far off a quarter of a sphere.
Right. Yeah. Yeah, so you can tell it came from above or below, and that's about it. Yeah.
Well, I think not much from below. Not genuine, but anyway, yeah. Anyway, I think we've got off track a bit, but it's very interesting question.
Oh no, but it's you know, I'm getting more interested in muons as a result of doing this, so that's quite good.
If anybody knows how to track down a scientist from the Pierre Auger observatory, do let me know, because I have been searching.
Paul, what struck me, I don't know, do you remember a couple of years back, Marek from Sheffield, he's in the particle physics department, gave a talk, and I know Lee Thompson at Sheffield, he's one of the other professors there, is involved in IceCube, I think, or something like that, which is another big detector. But I was thinking whether maybe one of those might be able to give an overview of you know, let's say steer us a bit on the statistical side of things, but also a view on what would be meaningful to think about in joining things up, you know, from the professionals, if you like.
Yeah, Lee Thompson is really good. I've had a bit of communication with him, and he did address us one evening.
Yeah, he was the year ahead of me at Sheffield when I did my PhD.
Oh, really?
I used to know Lee very well, but I haven't seen him for decades.
Yes, I've had a bit of contact with him. Okay, well, on that note, looking ahead, let's see where all this takes us. And thanks again, Rupert, and enjoy the rest of your evening, guys. Take care now.
Nice to see you in a few weeks.
Ruth,
Bye,
thank you
guys.
very much.
No problem.
Thank you.
Bye.
Thanks for being patient.